what is the magnetosphere? Magnetospheres individually encompass an area of space around various astronomical objects and control that object's magnetic field. Think of X-Men's Magneto and his superpowers. Now, an object's magnetosphere is dependent on a few different variables, including what the object is, its size, rotation pattern, axis rotational point, and the magnitude and velocity of approaching solar winds. For now, we're going to focus on Earth's magnetosphere. But first, let's define some terminology. First, we have the bow shock, a curved shape of volume that marks the beginning of a magnetosphere and takes the brunt of the impact of energy particles. Think of it as the Earth's equivalent of a car's crumple zone that protects it from most of the impacts of a crash. Moving closer to Earth, we have the magnetosheath, which acts as a buffer against pressure from oncoming solar winds. Solar winds are a continuous flow of charged particles from the sun that permeate our solar system, its outer space's equivalent of air. Beneath this layer is magnetopause, also known as the middle area of the magnetosphere. Here the planet's magnetic field is balanced with solar wind pressure. Spread throughout the magnetosphere is plasma, an ionized gas surrounding the Earth made up of positive ions and free electrons that result in little to no electrical charge. And finally, there are solar flares, brief eruptions of intense high-energy radiation from the sun's surface that have been known to sometimes interfere with communication here on Earth by disrupting radio frequencies and satellite communications. These flare-ups can also cause a unique phenomenon that can be seen in Earth's night sky, known as aurora borealis in the north and aurora australis in the south. These spectacular light shows have only been spotted near the poles and occur in Earth's atmosphere as a collision between the sun's intense radiation and magnetic energy found in the planet's magnetosphere. Now, Earth's magnetosphere begins about 60 miles outside of its atmosphere. There are 3 rings that exist within this area, each possessing different types of energy particles. First, there is the plasmasphere. Cold and dense, this area is filled with low-energy plasma that co-rotates along with the planet and is relatively harmless. The ring current is made up of protons and electrons, but the energy intensity is higher here, and the particles rotate in opposite directions of each other around the Earth. Finally, there are the Van Allen radiation belts. Both are comprised of high-energy particles, though the inner ring contains protons and electrons, while the outer ring has only electrons. All of these different areas are held together by magnetic field lines that extend from Earth's molten metal core and out through the north and south poles to form a shield that protects us from solar wind and flares. High-energy particles coiled around these lines protect us by bouncing from pole to pole at varying speeds. Remember that cool space phenomenon from earlier called aurora borealis? Well, to get very specific, these lights are residual energy from the sun that made it into the planet's atmosphere. This happens when the particles dancing around the magnetic field lines collide with the sun's oncoming energy and become so intense that they cancel each other out. Whatever energy is left is drawn to the north and south poles and gradually leaks into Earth's atmosphere. These beautiful lights have been observed for centuries, however the exact science has been a long thought about mystery. Until recently, our understanding of the magnetosphere has been fairly limited. To better understand this phenomenon, NASA developed the Van Allen space probes, formerly known as the Radiation Belt Storm probes, which were launched into space during the summer of 2012 as part of the Living with a Star program. These 2 probes were designed to observe the different fluctuations in the magnetosphere and its interactions with other astronomical entities. Scientists continue to gather new data as the probes journey around our planet through the magnetosphere to observe the vast universe.